let's take another method that we wrote using standard recursion and write it using tail recursion. So instead of doing something that operates over numbers, we're going to instead write something that operates over strings. So what that means is that we're going to have an accumulator that also is a string. So one thing that I've sort of failed to mention in the previous videos is that when you're writing a tail recursive method, your accumulator is likely, not always, but is very likely going to be a value or of a type that is the same type as your return value for your tail recursive method. This is not always the case, so it's not an absolute, but it's a general idea to kind of get you started. Okay, so remember the swap problem is that we have a string and we want to swap all occurrences of the string AB with the string BA. My cat is going crazy. I am sorry about that. Okay, so how are we going to do this? Well, once again, what are we going to do? We're going to write a driver method, or a driver and a helper method. So let's write the swap ABTR helper. We're going to pass in the string, because of course we're going to use that. And then we might use some accumulator, so we'll come back to that. Okay, so let's now write so let's first remember the rule. This must be private. So private static string swap ABTR helper string s and then some accumulators that we might get. And again, we're going to just copy and paste our code. Literally, copy and paste our code, and then we're going to change what we do in these cases. So here we're going to do something else, and then here we actually don't need to get rid of this code because there's nothing tail recursive about this. This is just some extra stuff that might help us write the tail recursive method. Okay, but this is going to have to change. So let's just comment that out, and we'll keep it in our mind. Okay, so immediately we're going to write return, and then we're going to create a recursive call, or a tail recursive call. So remember, there must be nothing on either side of the invocation. So what are we doing here? Well, we're going to, so remember that when we did this with factorial, the idea was that we wanted to move this multiplication operation inward to a parameter. Okay, so we want to do something similar here, but instead of moving in a multiplication, we want to move in a concatenation. Okay, so how are we going to do that? Well, we can do something very simple, actually. We can just make a string accumulator, return that accumulator. Well, we'll come back to that. But we're going to, first of all, so the recursive call is actually still going to be the same. We're going to be passing x, but then we're going to do something with this accumulator, and something with w, and something with BA. Okay? So what are we going to do? We're going to take the accumulator, append w onto the end of it, and then append BA onto the end of that. Okay? So really, we're just moving this operation, or rather the whole thing, inward into the recursive call. Okay? So it's important to think about what happens when we do this. So, or rather, it's also more important to think about what we need to do when we return from this method. So you might think, well, why not just return ACC? Just do that. Okay, and that's a good guess. So we'll go with this for a minute, and let's also think about what our starting accumulator is going to be. So there's a couple options for this. Now, in this case, we actually don't return something like the empty string or a 1 or a 0 in the case of count chars. Okay, what do we do instead? We return S. So you could just put S here, but there's two options to this, and we're going to explore both of them. So let's think about what happens if we just put S here. Okay, so I'm kind of realizing that I thought this was going to be problematic, but it's not really going to be problematic. In fact, this will work. So let's just run it, and we'll see what it does. Or it doesn't work. Wait a minute, what's wrong? Let's see here. So this one fails. Let's see here. Okay, let me think about this for a minute. Okay, so this is kind of what I expected. So this is the problem. So if we just have S here, then that means that our accumulator is going to start out as S. But what that means is that no matter what S is, we're just going to append that to ACC, and that's the problem here. So that means that our entire string is just going to be passed to our accumulator, and then we're going to append some other stuff on top of that. So that's not good. So why not try the empty string? Because when we start off the standard recursive call, we do just have an empty string that we're starting with, right? Because when we've just made one recursive call, we don't have any concatenation sort of queued up, so to speak, which means that we start with the empty string. Okay, well, let's think about what happens when we do that. So we get some tests that fail. Actually, we get multiple tests that fail. Actually, I think all of these fail, which is kind of interesting. Well, not all of them, just some of them. So this test fails. And this test, it says expected B, but the actual was the empty string. So why is that? Let's explore. So notice that we call the method with swap abtr helper. We have S, and then we have the empty string. So when we call this, we're going to say if S does not contain AB. Does S contain AB? No, it doesn't, because it's just the string B. So we return the accumulator, which is just the empty string. So the issue is that we need to also append S onto the end of the string. So remember what we did before was that if there are no instances of AB in the string, then we just return the string itself. Okay? So the idea that I was sort of thinking about halfway through the video didn't really come to fruition, but that's fine because this is kind of what you should do anyway. So the starting value is the empty string, and then in the base case, we have return ACC plus S. Okay, so we return S here, but it's really like we're returning ACC plus S, where the accumulator is just the stuff we do after the recursive calls have finished. So if we fix that, then all tests pass.